Hello and welcome to our webinar for August. And we'd like to thank you for coming along today. My name is Scott and I'm from WarmlyYours. And we have today with us.
I'm Anatoly. I'm with WarmlyYours as well.
Well, what a coincidence. Thank you for joining us today. If you have any questions today, feel free to click on the Ask a Question button there at the bottom of the screen, and we will be glad to get to your questions. We have a couple questions we've received already from some people that have let us know in advance they'd like us to address those, so that's on the way. So let's go ahead and get started here. What we're going to be doing today is we're going to be going over the technology behind snow melting, a project example for a walkway, the installation process for a walkway. Then we're going to be moving on to a project example of stairs, and then the installation process of stairs, and then going over controls and wiring and how it all comes together and magically works. So, Anatoly, tell us about our snow melting systems.
Yeah, so our snow melting systems are generally compatible with kind of all your typical outdoor surfaces. So, concrete, asphalt, or mortar can be installed in mortar, sand, under pavers. Of course, the best to install it is when that new area is being done. However, we do have products and design abilities to get the system prepared and designed for a retrofit application for that existing concrete or maybe existing asphalt surface.
Yeah, so these are great systems for ramps, walkways, stairs, driveways, anything that you'd like to make sure that you don't have covered with snow during your winter time. It's perfect for those types of jobs. So what do they need to do to get started to get this order process underway?
Yeah, so if it's very simple, square rectangular area, of course, just the length and width would do it most of the time. If it's just slightly more complex, simply send us a very simplified sketch as long as it has all the correct and accurate dimensions on it. That would do it. We don't necessarily need some high-tech blueprint to get things done as long as we have the right dimensions and the sketch. That will do it. Our design team will pretty much work and put your layout into a CAD software and then work on preparing a nice, easy to follow layout. Either it's for a mat product that we're going to be talking about later or a cable product, but pretty much you're getting a nice layout plan. You're getting a nice itemized quote in the end. And also together with that, you're getting an electrical plan, which would be pretty much a gold piece of paper for your electrician to follow and get all the important information.
Right. So the main thing about this is send us a simple plan, and then we will figure it out for you. There's no reason, especially if it's the first time you've ever done a snow melting installation, you don't have to put it upon yourself to go, okay, I've got this many square feet, then I've got that many square feet. How many breakers do I need? How many cables am I going to use, or how many of this or how many of that? I need to figure all this out. No, you don't need to figure out all that. Just send us a sketch of the area, and our professional engineers that do this every day of the year, they will be able to get that plan together for you and to save you all kinds of time and heartache trying to figure out what product is going to be going into your floor or into your driveway or walkway or whatever it is. So give us some background on electric snow melt technology and how it looks so cool on the picture on the right versus these people on the left, which are not embracing the electric snow melting technology.
Yeah, sure. So electric snow melting technology is, generally speaking, pretty simple and straightforward. If you think about electric heating cable, it has a resistance. Of course, we're talking about a heating cable that would have a specific resistance in it. In the end of the day, when electricity applied to it, it heats up. So the technology is very similar as to the technology of electric floor heating. You have a heating cable, it heats up. Eventually, because we are outdoors and we're melting snow, it needs to be a more powerful system. So of course, we don't bring as low power as for floor heat. We bring in more power for a proper melting of a snow outside. And then in the end of the day, again, we're gonna just in the next slide showing you the mats versus cable systems. But in the end of the day, you have either evenly spaced cable for a mat we have in 2 feet or 3 feet wide sections, unrolled, embedded in concrete or in sand under pavers, let's say, those are being applied with electricity. Electricity causes those resistive heating elements to heat up. Heat is being conducted into your surface, melts the snow. I know it all sounds maybe very simple the way I'm saying, but in the end of the day, it's really that plain and simple.
It's like floor heating on steroids. It's just you're doing the same type of thing, only you're doing it outdoors and in larger spaces. And the thing to keep in mind when it comes to electric heating, a couple things. If you have the correct control, the control will make it so it will melt the snow and then evaporate it, so you have a dry surface left behind. You just don't melt the snow and then let it refreeze. So we have the technology in our controllers to actually melt the snow, evaporate it, so you don't have black ice and that sort of stuff, or embedded, especially when it comes to pavers, that embedded ice and snow that's below in the grout line where you can never ever get rid of it. Also, electric snow melting is much more efficient than hydronic, simply because as soon as hot water leaves the boiler, it begins to cool off, and it even cools off from the boiler until it gets outside. So now you're dealing with water that's this temperature, it gets outside and it's this temperature, and then by the end of the run it's this temperature. The thing with electric heat is it is this temperature and it stays there the entire width and the entire length of the installation. The beginning of the cable is just as warm as the end. With hydronic, the water coming in is always going to be much warmer than the water coming out. So that's what's such a big benefit of electric heating. However, doing very, very large spaces can be difficult to power. So we're going to be talking about different kinds of coverages to allow you to get a nice approach from the road up to your driveway and to your garage, using whatever power you happen to have. So sometimes it can be done, and sometimes there's just simply not enough power available. So when you're thinking about doing your installation, go out and look at your breaker box and see if you have any spare breaker spaces. Because if your breaker box is completely full, you're not going to be able to get any electric snow melting in there unless you get an additional box. So that's always a good thing. The first thing is to see if you have any room in your breaker panel for more breakers. So let's go ahead and go to our next slide, and that is going to be the snow melt systems. What's available?
Yeah, so let's start with the voltage first. So we have our products available in 120, 240, 208, and 277 volts. To be exact, 208 and 277 volt systems are available in cables only, while 120 and 240 are available in both mats and cables. Of course, as you can see on the right side of the plan, that's what I already touched up a little bit. That's spool of cable. That's eventually what we call a snow melting cable. Comes in a spool, loose cable that you follow the plan layout, attach it with plastic zip ties, and getting your coverage done. Just under it is the snow melting mat, or mat in this case. We do have those in a 2-foot wide and at 3-foot wide versions, and of course various lengths. So these are your two main types of the product. And of course, at the end of the day, each order will come with that customized install plan. That's where you see the proper layout. You see your electrical detail specifications, breakers needed, total amperage, which Scott was talking about. So that's what you see on the order and, of course, on every quote, so you can properly prepare for your installation.
Yeah, and the 3-inch spacing provides around 50 watts per square foot. Now, with the cable is you can do 3-inch spacing, or you can do 3.5, or you can do 4. You can cover wider areas, but as you spread the cable apart, the watts per square foot goes down. So some places where it's really, really cold, you want 3-inch spacing. Some places where it's warmer climate, you don't get a lot of snow, you can go sometimes out to 4-inch spacing. So what we do is we take and figure that out for you too. If you're in a geographic area that doesn't really require 3-inch spacing, then you can sometimes go to 4-inch spacing, reducing the amount of power you need, and also reducing your electrical cost, and also reducing your product cost when you're buying it right at the beginning. And it's very, very thin. It's only about 1/4 of an inch thick. So that's what you're going to do. One of the great things about our product is the color of the leads are color coded, so you know exactly what product is being installed. Different colors, red, black, and green, the change of the color from red to yellow or to blue or to brown, that is going to tell you what the voltage is, and that helps eliminate problems with the electrician hooking up the wrong voltage to the product being installed. So we color code those for your safety to make sure that you're installing what should be installed. So let's take a look at this snow melting system. And this house obviously has some trouble either getting up to their garage in the wintertime or sliding down their driveway into the street. Both of those are fairly dangerous. So that's what's so good about this full coverage. So tell us about full coverage.
Yeah, so full coverage eventually, as the name simply says, gives you that full area being covered, whichever area the dimensions you will be providing to us. So like in this case, eventually it's going to be that full driveway, fully covered, where almost every square foot of it will be will have the system installed under it, which will provide that heating and melting. However, again, in many cases, you can switch to a tire track coverage, which will just have a 2 feet wide or a 3 foot wide tracks just for your car to eventually drive in and out. The track going to be fully melted, and the areas to the side of it and in the middle will have some snow on it, just as the other areas that are not melted. And of course, again, tire track would typically be your great option if you want to save on cost potentially. Most of the time, it's going to be your best option if you're trying to reduce your total amperage, because that's where you can really, go from, let's say, 300 amps that you don't have, because let's say you only have 200 amp service coming to the house, to something like 100 amps or less, and still get the system done, get the system connected without inquiring any, expensive fees for upgrading your service, for example.
And also you can do a hybrid too. You can do 12 foot out from your garage, have it melt fully, and then do tire tracks down the remainder of the way. Or if you're concerned about, you have a long driveway and you're concerned with it's a descending into a street, you can do a 10 foot deep area there. So you have a place to stop before you go into the street. So there's a lot of different ways to get your area covered, do a hybrid coverage, tire track and full coverage. And just to be honest with you, we get a lot of people that are interested in snow melting and they don't have any experience in it. So invariably, they're going to just assume that they want to heat every square inch until they get the thing back and says that's going to be 400 amps and they only have 200 amps. So they go then, okay, well, what can we do? Okay, we can reduce it down the tire tracks, and they go, oh, that's great. That allows me to get in and out. So the first thought from a neophyte is going to be, I'm going to heat every square inch. Let's go ahead and heat every square inch. Well, when it comes down to practicality, we may be getting tire tracks and a heated area in front of the garage. So there's a lot of different ways that you can do, and you can approach your driveway. So let's take a look at the guts of this operation. So what's going on in this concrete setup here?
So yeah, that's our nice view on the cross section, and eventually this is cross section for snow melting cable in the concrete. So kind of starting from the very bottom, we're going to start with your base, which, in this case, we talk about compacted gravel, roughly 4 to 12 inches, depending what's needed for your particular system area and things like that. You want to then suspend your rebar or metal frame about 2 to 3 inches from that surface. And that's where eventually you're going to be tying your snow melting cable with a plastic zip ties, following that layout, and you tying that to that metal frame. And the reason we want the system to be suspended on those concrete blocks, or it could be metal chairs, pretty much something to suspend it to 3 inches, so that when on your final step, when you pour in your concrete, and let's say it's 4, 5, maybe 6 inches of concrete, when you're pouring that, your heating system will stay kind of right in the middle of that pour. So you're going to have 2 to 3 inches of concrete below, 2 to 3 inches of concrete below, on top of it, depending on what your total thickness is. And that's pretty much your golden rule. You want to always roughly stay in the middle of your pour for that proper heat radiation and transfer into the surface and for that further melting.
Right. Very, very important to keep it in the middle of the slab. The deeper it is, the more it has to travel through. The surface is going to, the deeper it is, the more the surface is going to take longer to melt, and also the surface is going to be cooler. The National Electric Code, you have to keep in mind, whenever you're doing a big installation like this with electricity, the National Electric Code has some rules that have to do with doing this installation, and that is that the cable or the mesh or the cable attached to the mesh has to be at least 1.5 inches below the surface. That's their rule. So you do not want it 1/2 inch from the top surface because it doesn't comply with the electrical code. That's why you need to get it down under there. And if you have a 4-inch slab, the best place to do is just aim for the middle, 2 inches above, 2 inches below, and then you comply with both sides of the requirement for the National Electric Code. One thing to keep in mind is if you're going to be doing a concrete setup like this, and you're going to be using the rolls with the mesh, you need to make sure that your concrete professional uses a sub 3/4 inch aggregate to allow the concrete to pour completely through the mesh. If you use larger chunks than that, the mesh will act like a strainer, and all the liquid concrete will go below, and all the aggregate will be on the top. So one thing when working with this and you're using the mesh is sub 3/4 inch aggregate. That's the secret. That's going to give you a great mix when it comes to your concrete slab. So before we get this installed, we have to make sure that something didn't happen to it between here and the customer. And we also need to make sure that nothing happened to it during the installation or during the layout. And we want to make sure that it's good after we're done. How do we do that?
So testing, and no, it's not. I'm not testing the audio here. I'm actually saying testing, and one more time testing. You want to do that pretty much, I like to say it before and after every major part of your install. And the testing needs to be done. You will really want to have 2 main devices, or I mean, sometimes it could be combined in one, but you want to have your digital multimeter for your standard testing. And in addition to that, you want to have a mega ohm meter, which in some cases with some good devices, it can be all combined into one, of course, but mega ohm meter is the important tool that maybe, again, not every electrician or not every installer will have, but that's the tool that tests the insulation resistance. So in addition to your regular testing of your whole line to ensure you get the right voltage for the right resistance for that right distance, you're also testing then the resistance between the core element and the ground sheet. So in other words, you're testing if there is any short and also if there are any insulation damages by using that digital, I mean, it could be a regular, but mega ohm meter. And the main difference between those two is that mega ohm meter sends 500-volt signal to actually test that insulation resistance. And that's why it's important, because it pretty much becomes more sensitive tool to find those problematic spots.
Right. So an ohm meter is sending 6 volts or 9 volts down the line, and it's testing the circuit to make sure the circuit's intact and the numbers of ohms are correct from what you're supposed to be finding. The mega ohm is actually testing the resistance of the insulation that keeps the line away from the ground. That's what the line and the ground can cause a short. It's testing the insulation between them to make sure that it's intact all the way through your system. So that's where the 500 volts comes through. So let's go ahead and move on to our walkway installation that we're doing in concrete. This particular job is a job that I did. I took these photos, and we can see how it was laid out and done. So let's, the first step, once you send us the drawing, is we will then do the drawing for you. And what we see right here is that drawing. So here we can see a SmartPlan. And Anatoly, can you tell us what a SmartPlan is and what it does?
Yeah, so I think the reason we like to add, and we adding and call it a SmartPlan, is because it's not just a plan layout that shows your area or plan that just shows the cable layout. In addition to, of course, the layout, which is your really the most important piece of information here. You can see the start point of your cable that is shown with a triangle. You can clearly see the layout, the distance, the spacing. You see the black square, which represents as the end of the cable. In addition to that, we of course show what the spacing needs to be used. And most importantly, on the top right section of that plan, you can see the part number for the cable. You can see the total amperage, resistance, the length of the cold lead, pretty much all of your important preliminary information to get in the project plan. Get your location maybe for the junction box figure to understand how long that cold lead is. So you can plan the conduit runs and things like that. And of course, in addition to that, more information is down below, like I was saying earlier, total amperage, total wattage, your operating cost, and number of breakers needed for that particular setup. So we, in addition to that plan, which, like I said, is the most important part, we adding lots of important information that would be needed at that time of the preparation.
One of the most common questions we get is, what is a GFEP breaker? A GFEP breaker is a ground fault protection for equipment breaker that is required by the National Electric Code. That is the type of breaker you have to use. There's no choice. You don't get the choice of regular GFI or GFEP. You must use a GFEP breaker because they are a 30 milliamp trip breaker as opposed to a GFI, which is 5 milliamp. 5 milliamp is too low for outdoor installations. Little small problems can cause a problem that could lead to what we call nuisance tripping. So that's why ground fault protection for equipment, or ground fault equipment protection, you see them both ways, GFEP or GFPE. Those breakers are 30 milliamp trip. They are required by the National Electric Code, and you cannot substitute a GFCI for it. It must be GFEP. So that's one thing. We get questions about that all the time. So I just wanted to make sure that we got that addressed today in our webinar, because it's a very common thing that we get every day here at Warmly Yours. So let's talk about surface material and what a one-stage pour is and what a two-stage pour is.
Yeah, so of course we talk about that concrete installation, and as you've seen in the previous cross section, we were just showing you kind of all the details, all the kind of layer by layer structure. Now, when it comes to actual installation, the system can be installed in two different methods. It could be one-stage pour, so kind of what we were talking about earlier, where you have the heating system suspended, you got it all secured. You pour that all concrete, let's say all 4 inches in one pour, your system stays in the middle, you are more or less done. You can also do a two-stage pour, where you're going to be pouring your first layer of, let's say, 2 inches of concrete. You can have your system installed on top of it. You can pour your second layer of concrete on the system eventually to get that total of 4 inches.
Right, and I think the pictures of here, I know this job was a two-stage installation, so the pictures that are going to follow is going to be kind of following that two-stage pour. So let's go ahead and move on to our next and talk about our foundation. Here we can see those bricks, and we can see that rebar once again holding up that. So go ahead and what else can they use to hold these, to prop this stuff up?
So yeah, I mean, it really can be lots of materials can be used. You can use just bricks, you can use stones, you can use metal chairs, pretty much anything that works okay with your material you're going to be using, and that gives that even height. So eventually you have that even height throughout the whole surface, because even height is important for your heating system. You don't want to have a section of it being higher in this step and the section of it being sitting like really deep. So as long as you maintain that midline, that's really what you're looking for.
Now, one thing that we haven't, we haven't talked about, and it's barely visible in this picture, but I can tell you because I was there and I remember. If we look up here, if you can see my cursor moving there at all, when you're doing this, you also have to have your electrician there. Your electrician has to put in conduit that stubs into the concrete that allows the cold leads to run out the side of the sidewalk, in this case, into a junction box. The cable must be protected according to the National Electric Code. It needs to be protected by conduit, which is stubbed into the wall or the form here. So we can see the wooden form here. Down here is a hole, a round hole saw was used to stub in that piece of conduit. And then that allows the non-heating leads to run out into that conduit and then down into a junction box. So your electrician must have been here at this point already, because they are going to have to get that electrician plan that Anatoly was speaking about. They're then going to have to go, okay, here's where the junction boxes are. I need to get those junction boxes installed. I need to get the conduit run to stub it into the wall of the form. And then that way, when we're ready to install it, we just stick the cold lead into that conduit and run it down into the junction box. That's a very, very important point. So your electrician is going to actually have to be here before this takes place in this picture. So let's go ahead and go to the next slide, and we can talk about installing the snow melt on the walkway. And here we can see that it is a two-stage pour because the concrete's already under here, right? Because I think I see some more concrete over there.
Yeah, definitely. We got already first layer of concrete. System is being unrolled and placed over that first layer. The important part to point out here is you can see the person actually holding that pinkish looking board, and that's actually going to be that separation between the two pours, or eventually between the two separate flaps, which in this case we're just going to call it expansion joint. And you can see how the system that we are installing to the right eventually is not crossing that expansion joint. So that's a general rule. You don't want to cross the expansion joint because these are two separate monolithic steps, two separate pieces of concrete. So if one moves, you don't want to have that cable crossing and being snapped because, 5 years down the road, they move 1 inch apart or 1 inch, up and down. So very important when you're sending the sketch to us that I was talking earlier, very important to, of course, point out where you are planning to have expansion joints, or eventually have your concrete professional point out or share it with us, because then we will simply incorporate that in our layout. We will ensure that none of the systems, none of the cables are crossing that expansion joint, and your system going to be, your plan can be ready to go with those joints prepared already, taking it to the account.
Yeah, and you can see right here that we have that board, which is what, old school was you put a piece of felt board or insulation in there, and that was your expansion joint. Now, a lot of times they just use a saw and cut all the way through it. So it's important to realize that you have two different kinds of joints. You have a control joint, which is usually only about 1 inch deep on a 4-inch slab, that safely the cable is down below that, and a cable can run under a control joint, but a cable should not run through an expansion joint, because you have this going on, and as soon as it goes like this, then the cable snaps, and you don't want that. So if you can, we don't really see it in this picture, but there is a junction box, and it's hidden here by this shrubbery. That's where the junction box is located for this run of cable that's going down in the lower part. So you can actually put the junction box here and hide it. That's what a lot of people do. They don't want to see the junction box. So they can actually, if they wanted to, they could start the cable going this direction, going this direction towards the road, and then they could also do it if they wanted to and keep it in one junction box, start this cable on the right side and have it start from there. So that way you get both of those in a box over here, and that's a good way to hide that junction box, because the junction box is going to be required unless your system is right next to where your control is indoors. So very, very important to keep that in mind. Also, the concrete professional is not going to sit there with their truck running, waiting for you to have your fencing out and then start waiting for you to attach the cable to it. The cable has to be pre-attached to the fencing, and it has to be over on the side. And then once they're done pouring that first layer of concrete, you then take your fencing with the cable on it and drag it and lay it down, so the concrete professional could then put the second layer on there. They're not going to wait for you to string that cable back and forth and attach the cable ties. So be prepared for that. It has to be done very quickly while they're there. So keep that in mind while you're planning your job. That's why sometimes it's much easier just to do the one-step pour, because then the concrete person doesn't have to wait for anybody to do anything. They just start at the beginning, they pour, and they pour all the way through, and you're all done. Hopefully your electrician has got everything in place. So let's talk about stairs and the thing that stairs, the issues that we can have with stairs, or the design concerns, I should say, because you don't always have issues with stairs. It's just things you have to design. So tell us about this smart plan.
Yeah, so this SmartPlan eventually will have all the similar electrical information. I'm not going to be covering that anymore because we provide that for every single plan. You will see eventually here on this plan an expansion joint that separates your kind of landing area and the actual stairs. Also, two separate cables, cable number 1 that covers that L-shaped area, and cable number 2 that covers specifically the stairs. And on this plan, again, we're showing you particular layout, where to start it, how to follow, where to end, and all the dimensions. So you got your stair plan prepared that way.
So let's take a look at measuring, how to measure for stairs. What are the main things that we're asking? Like, what is tread? What is riser? What are those things? What do they mean, and how do they impact our measuring of stairs?
Generally speaking, since now we almost talked about 3 dimensions, we really want to have all your length and width, but also pretty much all the height transition, sort of speak, of where that cable will need to go. So in this particular diagram, you can see kind of that 3D view of the cable layout. So our designers will eventually need to know all of those details, of course, number of steps, thread risers, all that landing dimensions, to get you the proper calculation and a proper layout. Also, in addition to that, the important factors that in many cases could be forgotten are the additional obstructions. So like in this case, will there be any sleeves or posts installed where we don't want the cables to go? So like as you can see here, there are 4 spots that we need to sort of avoid running the cable through. Take that to the account when we're doing a design and ensure that we have the correct length, because remember that the cable cannot be cut to length. So you cannot just order one long cable, start looping that around, and get to the point where you're done with your stairs and just terminate it. That just doesn't work that way. So that's why getting the design done right, getting all of those tiny details on those sketches is important, because eventually then you're getting the right layout with the right length cable and pretty much ready to proceed with a perfect simple install.
Yeah, so tread is the depth of the stair. The riser is the distance from the top of one stair to the top of the other. So this is the riser. The depth of the stair that your foot hits is the tread. We also need to know the width, and that's all you need to do. We need to say it's 4 foot wide. I've got 10 steps. The tread depth is 12 inches. The riser's 8. And then we can do the rest and do the design for you. I can't tell you the number of times we've spoken to people who have called in and said, yeah, we just drilled for our handles and now the system doesn't work. The system doesn't work is because the cable was hit when they drilled out for these. We cannot tell you in a strong enough term to make sure you plan around any handrails that are going to go in. And the easiest way to do that is to install a metal sleeve when you're doing that, then installing the cable around, because that way there's no way the handrail post can hit the cable. It's real, it happens, and if you don't plan for it, you could be very upset. So let's talk about installing cable on stairs. Why aren't we using mesh and a roll?
So yeah, cable is your best product to go with stairs, because it's a flexible product. You don't have something that is 2 feet or 3 feet wide. You have a loose cable that you can position at whatever spacing you need, first of all, because in some cases you may want to go with a 2.5-inch spacing. In some cases, maybe you would go with a different spacing, but you're flexible with the spacing, you're flexible with that width and layout, and then of course you transition from one step to another. So definitely by default, all the time, we would typically design it with the cable. Then on this particular image, you can see that we have already, the pre-made existing stair that is ready to receive the system. So in order for proper positioning and spacing of that cable, you can use metal mesh, you can use a fiberglass mesh. Really, in this case, the goal is to install that cable at the right spacing and at the right layout. So this eventually gives you the uniform heating and uniform transition, and eventually, again, following the layout as we show it on the plan.
Awesome. And it's very important. The stairs are a very important part of the stairway. You've got a stoop or landing at the top, and you sometimes have a landing at the bottom. The stairs are very, very important. We're going to be talking about why that is here in just a little bit. So here we can see where we have forms. We're using forms. We're using cable attached to rebar suspended in the middle of the pour. So this looks like it could be a couple things. This could be a straight concrete stairway, or it could be that we are using a cap on there. A lot of times people use limestone caps that are 2 inches thick. So one thing that I have personally gone out and repaired myself is when people were setting limestone caps on the stairway. They started with an old concrete stairway. They're going to be putting limestone caps on the top to make them look great. Well, what happens is you're running a cable from one step down the riser to the other step, and when it goes from the riser to the step, it has to curve. You can't bend it in a 90-degree angle because cable doesn't work that way. You have to kind of loop it down and around. Well, when you take a concrete cap, a limestone cap, and you set it in the mortar and you start seesawing it back and forth, it's kind of like an old-fashioned saw. When you see these gentlemen from the 1890s with these gigantic saws working together to cut through these gigantic trees in the Pacific Northwest. Well, what you're doing, it's the same thing. You're taking that piece of limestone cap and you're pushing down on it with 2 or 3 people to set it, when actually there's a cable there that it's getting caught on, and they push and push and push and saw, and it cuts through the cable. So you have to be very careful when you're doing your installation of concrete, of limestone caps, to not damage the cable as it runs from the riser down to the stair. So what else are we doing? What else are we seeing here?
So this already has those kind of pre-made forming, and as you can see, it's kind of maybe hard to see, but you can see at the lower stair, a black metal chair is already set up. So now you have your wire mesh suspended at the right depth. You got your green cable installed according to the plan, and pretty much you are proceeding with that one stage installation, because you sort of have all your kind of homework pre-done here, and now it's just concrete time.
So there's a couple of things that we've learned. We've been doing this for a long time here. Over a decade, we've been selling snow melting products. And we talked about the stairways here. When they're using these limestone caps, Anatoly, what do they need to make sure they're doing with that cable on the stair?
So with a cable, first of all, you want to look at the right spacing. That's your number one thing, an important one. And you want to place that first run of the cable that is right on the very corner of every stair as close as possible to that corner. Just think about the limestone, let's say, like Scott was saying, you're going to have those extra, let's say, 1.5 or 2 inches of total material, the stone and maybe some sand or thin set or mortar under it. And if you look at that dotted line, which is eventually going to be your top surface, the very edge of that, or the very edge in the corner of that stair, are going to be pretty far away from the cable. So you don't want to have that cable sitting, 3 or 4 inches away diagonally from the very corner. You want to have it as close as possible so that line there is nicely heated and still gets a good mounting.
And that's what's so important about this particular drawing here, this pair of drawings. People love to have bull noses on their stairs because it makes them look so elegant. The further that bull nose is out away from the stair, the deeper it is, or the more it sticks out, the more ice and snow will be deposited there that will not get melted. So if you take a look at this, if you had your druthers, and I realize that some building codes do require a nose of some sort, and if that is required, then make sure the nose is as shallow as it can possibly be and comply with the building code, because the last thing you want to do is have a 2 or 3 inch bull nose sticking out from there. Because let's take a look at the thermodynamics of a stair. You have, if we go back to this picture here, I love going between these slides to show you the differences of things. So I'm going to click on this and take a look. Let's say that you are running out of cable. Let's say that your dimension is off or something, and you're out in the field and you have to get it installed correctly. If you have your druthers between changing the spacing on the stairs to take up less cable or changing your spacing on the landing to take up less space, so you go from 3 inch to 3.5, you would do it up here, but you would never change or never dilute the coverage on the stair. And why is that? It's better to make sure your stairs have as many runs as it'll fit, as opposed to the area above, because this area is not surrounded by cold air. I'm sorry, I keep clicking on the wrong place here. Take a look here. The flat area is only getting cold from above. But if you take a look at a stair, it's getting cold temperatures from above and from the side. Above and from the front, I should say. So this needs more BTUs to make that area melt. Now in Chicago, you see a lot of these brownstones where you walk upstairs to go to one, and then you walk around the stairs and go down to the residence below, the garden apartment, as whatever you want to call it. And that sometimes is an exposed concrete stairway. So now you're not only getting cold temperatures at the top, and from the front of where the riser is, you're now in those types, you're getting cold air from below. So you've got all this cold air surrounding these stairs. That's why if you're going to try to minimize or maximize coverage, you can space the cable a little bit wider on the landing, but you never want to change the spacing. You never want to dilute your coverage on the stairs. And I guess I'm pontificating a bit about it, but I can't tell you the number of times I've gone out to do inspections on stairways that weren't melting, and the first cable was away from the front of the stair. They had a 2 inch bull nose on the front, and they could never get rid of the frozen ring at the front. It's real world. We're trying to save you from learning that the hard way by telling, having things like this, so we get that out in the open. That is, if you want the front side of your stairway to melt, you need to make sure that you get that cable right on the front and make sure that that coverage is not diluted on that stair. So what's the minimum amount of spacing that one of these wires can be mounted from another heating wire? Minimum coverage.
So yeah, the minimum spacing that you can get on a snow melting cable should be no less than 2.5 inches. So 2.5 inches is still good, but you don't want to install it any tighter than that.
Because then the minimum bend radius of that cable is 2.5. So if you take that cable, it's got a 2.5 inch bend radius, and you bend it to 2, you could damage the cable. So that's what minimum bend radius is. When you see that in a spec somewhere, that's what they're talking about. So let's talk about the controls. Now that we talked about, here's what you need to look at, here's how you install it, watch out for this, make sure you install it correctly. We have to talk about the controls. How do you control it? And hopefully, and thank goodness we talked about what the electrician needs to do ahead of time by stubbing in the conduit and getting all that stuff, the junction boxes, ready before you even go out to lay out the cable, before you go out with the concrete person. That stuff all has to be done ahead of time. So let's talk about the controls and what needs to be figured out when it comes to that. So how do we get power from the breaker box or the control to the heating part of the floor or the walkway?
So first of all, let's start with getting eventually that connection from your, let's say, driveway out into the indoor location where the relay panel will be. So on that drawing here, you can see all the way to the left, we start, of course, with the heating cable. Then you have a hot and cold joint, which we also call factory splice. That's where your heating cable now connects with the cold lead, which is a non-heating wire that is typically 20 feet for most of the systems, except 208 and 277, that would be 50 feet. Let's just start with a 20-footer.
Just 1 second, Anatoly. Everything to the left of that hot-cold joint on this drawing heats up. Everything to the right of that hot-cold joint is cold. It doesn't heat up. The National Electric Code has differing rules about heating cable as opposed to non-heating cable. The non-heating cable can never go in the conduit, right?
The heating cable never goes in the conduit because it's just gonna cook and cook there until it just fails. So yeah, I'm gonna probably continue then with that cross section. So after you got from that heating part to a non-heating part, you have cold lead there, and the first inch to 6 inches of that cold lead, you still want to leave it in the concrete because it still can be partially heated, and that's how the code wants it. And then only after that distance, you can get cold lead in the conduit. And again, remember, you have 20 feet or in some cases 50 feet. You get that in the conduit, ideally to your indoor relay or control location if that's close by. If it's not close by, you would get it to a junction box, and then from there, electrician will just run his own wire. You know, if we're talking about a long driveway and that current location is, let's say, 40 feet away, you then electrician will eventually run his own wire to your preferred location where the relay panel will be or where the control will be. And pretty much by doing that sort of splice connection inside the junction box, now you're getting all your power finally to the heating system.
Yeah, and excuse me. A lot of times people will go, I want to extend my cold leads. The cold leads aren't long enough to get inside to my house. Do we sell cold lead extensions?
Not really. So yeah, like I was saying, there's really no such thing as a cold lead extension because, you know, in some cases you would need extra 10 feet. In some cases you may need extra 110 feet, depending on where you're working on, where you're extending, and what distance you need to extend. So that's all that electrician would typically be providing with no problem. There's nothing special about that. You would just need to eventually size his wire, measure his wire, and when I say size, I mean, of course, sizing the gauge of the wire based on the amperage of the product that he's extending.
Right. So the main thing here is this drawing is a great drawing because it shows that conduit being stubbed into the concrete like it has to be. That cable never leaving this and entering air anywhere. It goes through the conduit to a junction box. That's all the cold lead is designed to do. Get from the heating surface through a tube and into a box. That's all it's there for. So it's very, very important when you're doing an installation is to not walk or not bend the factory splice there, where it talks about the hot cold joint. If you bend it to try to fit it into a tube, you'll break it and you'll cause your system to fail. I've been out on a couple jobs where they bent it trying to get it in the conduit. We had to replace the whole thing. Also, we've seen cases where that hot and cold splice has been put in the conduit and it's had to been broken up and get it back there for code reasons. So you just need to make sure if you follow this simple drawing, you're going to have a very good chance of not having a problem. Making sure that you do not walk on the factory splice. So how do you keep track of where the factory splice is? You're doing a 200 square foot room, you're pouring concrete inside, or you're pouring a slab outdoors. Once you cover it with concrete, how do you know where that slab is? Because you're walking around in that wet concrete, and how do you know where that cold splice is? The secret to that is get one of those little marker flags with the orange flag and a piece of metal, like that real thin piece of wire with the orange flag on it. Stick it in ahead of time where that splice is, and that way when the people are there installing it, they hit that flag, they know, oops, Right there is where the splice is. And then when they're ready to move away from there, they take the flag out and they finish it. So very, very important not to step on that splice also. The cable's very, very resilient, except the splice isn't. So that's why you never drive anything over the heating cables. You never drive over an exposed cable, that sort of thing. But that's finer point stuff that we'll get to later. So let's talk now about the actual snow melt controls. So what kind of controls do we have here?
So while it's a lot of different controls with different names, I like to start with dividing those into sort of manual controls and fully automatic controls that run automatically with a sensor. So if you look at those, the Wi-Fi on the top left and the timer control at the lower left, those going to be your manual control that has those additional abilities of running that on the timer, running that on the remote Wi-Fi connection, things like that. But the reason I'm saying manual is because they do not know what conditions are outside. They don't know if it's raining, snowing, or it's minus 50 degrees. All other controllers you see in here are fully automatic when they are running and installed together with the sensor. And typical application with a sensor would mean that the sensor detects precipitation and the outdoor temperature. And for most of these sensors or most of these systems, your default default algorithm, I would call it, would be that when the temperature is below 38 and there is precipitation on the sensor, that would give a signal to the controller to turn on the system. And again, that's your great way of fully automatically running the system exactly when it's needed. And then when, let's say, the snow stops, the sensor is, by the way, I should have mentioned that earlier, the sensor itself has a little heating element, so it's heated. So if the snow falls on it, it turns into water. That's actually the trick how the sensor knows that there is precipitation. But when the snow stops, eventually that last snowflake melted, the water evaporated or drained a little bit. The sensor no longer sends it. It stops tells that to the controller, and then the controller just runs for extra couple of hours to ensure that all that potential snow or potential melted snow or just water either evaporates or not refreezes on the surface. So that's your kind of typical 2-minute explanation of how automatic controller works.
All these controllers go indoors except for which one?
So you can still install the premium or advanced controller outdoors. They are rated for that. However, we still recommend them to have it indoors because that's eventually how conveniently you can control it. However, the value controller you're seeing on the lower right corner, that's actually a great controller. I like it. It's a combination of a controller and a sensor all in one cone-shaped device. So this one definitely needs to go outdoors because it's a sensor. So eventually there's no reason to place it indoor. You want to have it outdoor in a typical average location for the sensor.
When it comes to a couple of these things like the power modulator is the control that allows you to work in zones. If you have 100 amps available, it'll turn on 100 amps, turn it off, turn on 100 amps, turn it off, turn on 100 amps and turn it off, and just keep going like in a circle like that. That's how you can heat larger areas with a smaller amount of power. These two controls in the upper right-hand corner, the premium and the advanced, they do come in weatherproof boxes, but you do not want to put them outdoors because let's say that those are automatic, but you can also manually turn them on and manually turn them off if you need to. The last thing you want to do is make your customer walk outdoors, open up this thing in case it's locked, then you have to unlock it, take the cover off, hit start, put the cover back on, lock it back up and walk around back inside. They're able to be mounted outdoors, but you really, really, really want them mounted indoors. So the user doesn't have to walk outside to turn them on and off manually. And that's what's so great about these is they're automatic, but you can also turn them on manually if you need to. So let's take a quick look at sensor placement, and there's a lot of science going on here. So you folks that are going to watch this recording, you can stop it and look at all this great stuff. But in a nutshell, Anatoly, so we don't run over our time and run into tomorrow, what is the main thing you need to worry about with your outdoor sensor? What's the main point? And all these tertiary points are great, but what's the main point about placing your sensor outdoors?
The main point, I mean, the shortest, probably best way to say it would be you want to have a sensor in an area that will get a normal and average amount of snowfall, and it's not going to be covered or impacted by something where it's going to have a delayed snowfall or pretty much no snowfall at all. So just normal average spot, not 5 inches away from the building, not under an overhang or a tree.
Right. So keep them away from the buildings, keep them away from heat sources, that sort of thing. The main thing is and for most of these sensors is put them where you can get at them, but they cannot be damaged by vandals, because you do have to clean the sensor once a year before the snow season, clean that grid at the top that Anatoly was speaking about, the heated grid. You have to clean that off because birds love those, and birds will make a nest on that heated grid if they can. So you need to clean that off. So you need to be able to get at that, but you also want to put it like 7 or 8 feet high so a vandal who doesn't have a ladder can't get at it. So those are the main things. Put it where someone can't damage it, somewhere where it can be cleaned, and somewhere where the snow hits it every time it snows. Not up against a house, not under an eave. So hopefully that kept it short and sweet as much as we could. So let's talk about these relays. And the number one thing I want to say about these relays is these relays should always be mounted indoors. These relay panels come in a NEMA 1 box. Now, if you're an electrician, you're supposed to know what NEMA 1, NEMA 2, NEMA 3, 3X or 3R, NEMA 4, whatever those are. NEMA 1 means indoors only, because we have seen, haven't we, Anatoly, where these things get mounted outdoors and all of a sudden these parts that are not supposed to be outdoors all of a sudden are getting rained on, getting snowed on,
Yep.
water dripping, that sort of thing. So go ahead and tell us what's the difference between these panels.
Yeah, so eventually these are relay panels. We offer 3 different sizes, small, medium, and large. And most of the time you don't even need to worry about these sizes because we get this sized up for you based on the number of heating elements that you're going to have in your system. But think about the relay panel as a simple contactor that gets that signal from your controller. So anytime your controller says, yes, it's snowing, we need to run that system, it sends a signal. If it's a small relay panel or, let's just call it a small relay panel with contactors inside and system connected to it, it will just activate all of these contactors that are in and get the juice flowing to your system, get that system up and running. So simply think about that as a panel with all of your wiring pre-made there, pre-connected after, of course, all the installation that runs the system.
So the one thing to keep in mind with this is sizing. This is how we do it. You don't need to remember this, but it's good to know, is 120 volt and 277, we only switch the hots. So you only need 1 pole. So let's take a quick look at this box. We can see that we actually have 1, 2, 3, 4 relays in there, which means there are 8 poles. 4 relays, 2 poles apiece. So a 240 or a 208 will be using 2 poles per cable. A 120 or a 277 use 1 pole per cable. So if you have 4 120 volt cables, you can use 4 poles. If you have 4 240 volt, you need 8 poles. That's as in-depth as we're going to get, because 208 and 240 require 2 poles, switching 2 hots, and 120 and 277 require 1 pole, switching 1 hot, and the neutrals are tied together. So let's take a look at the grand scheme of things here and see how it's kind of like a simplistic map, which we're going to kind of talk about what the parts are. Then we're going to show you where they lie, indoors or outdoors, on our next slide. So go ahead and explain to us what's going on here.
Yeah, so I'm going to start with the sensor, because eventually that's your main trigger. That's eventually what receives that snowfall, what senses the temperature. So the yellow sensor sends the signal to the control unit. And when we talk in signal on these particular diagram, we're talking about those green lines. So it sends the signal to the control unit that, yes, it's snowing, yes, it's cold, need to run. Control unit eventually activates its own small relay that sends that green arrow down to the sends a signal, of course, to the relay panel. And the relay panel, the one we just were talking about, relay panel, let's say, has 8 of these heating mats. It activates the contactors. So now that power that you see in an orange arrow from the right, 120, 208, 240, 277 supply, that supply now is finally being released and going into your heating system. So that's in a short, quick description. That's how the whole flow is happening. Of course, I missed that. Your top orange line is just simple 120-volt supply that just making sure that your control unit is always getting power and it's always on standby. That's why we say it's a low draw.
Yeah, the control unit is the brain, the sensor is the eyes or the touch, and then the control unit says, okay, I see, the sensor sees water and it's cold. I'm going to send power to the relay panel, and the relay panel is going to click all those relays together, so all the power coming to the relay panel from the breaker panel then is kicked on, and then it goes into heat that surface outdoors. Now, what I'd like to get everybody's attention here is this little dotted line here in the middle of the of this. And what is this little dotted line showing us?
So that line shows pretty much a separation to what's inside, which is to the left of that dotted line, and what's outside to the right of that dotted line. And of course, as you can see, your breaker panel, which is of course inside, your relay panel, which is NEMA 1 rated, so it again needs to be inside. Your controller and optional remote control override is also inside. But then your junction box, which we spoke about earlier today, the kind of box where you're making that extension to the cold lead, and your heating system and the sensors are all outside, because that's essentially the parts of the system that needs to be outside.
Yeah, so the main takeaway from this is it shows you what's expected to be inside and what's expected to be outdoors, and also that the wires, the cold leads from the mats, were never designed to get to the relay panel. They're simply designed to get to the junction box, and then the electrician supplies the wire between the junction box and the relay panel. That electrician has to size that. They size it on the amp load, and they also size it on the length of the cable. So voltage drop needs to be figured in, and the voltage drop is the measurement from the relay panel to the J box. So that's what your electrician is going to be there, and they're going to be figuring that all out ahead of time. So let's take a look at what important things that we need to remember to make sure, because if we do remember these, if we print these out, if we follow these, you are going to have a pretty good chance of having a very successful installation. And it's amazing how you can put it in a nutshell this small. If you can do this installation following what's on this sheet, you are going to have the best success in your life. And you'd be surprised how many people don't. So what do we need to keep in mind? The important things. I can just tell you, the people that tend to not have a lot of success are the ones that don't read the installation manual and they don't watch a video. Because this is such a big installation, please read the install manual, because it's full of information and it's really not that long. It's not War and Peace. You're not going to be reading it over a weekend. It's not 2,000 pages, but please look at that. And what are the important things in a nutshell to remember?
Yeah, so never had the heating element. I mentioned that earlier. That applies to, not shortening the element, not just cutting that. Just forget it. Don't cut the heating element. That's all I'm going to say. Then when it comes to actual installation, you never want to fold or position the heating elements so it like overlaps or sits literally, an inch or half an inch away from each other. That's just going to cause those two heating elements or overlapping elements creating way too much heat that's just going to kind of overheat itself. Never run the cold lead and sensor wire across the heating element. Same approach here. Your cold lead and sensor wire is not really rated to accept such high temperatures. So the heating, you don't want that heating element just, again, burning those wires. And when it comes to installation, again, spacing is important. You want to maintain that consistent spacing. And you never want to connect the heating rolls or cables kind of together to each other in series. I mean, first of all, They are not made to be connected. There's not even connectors for that. But again, don't try to get connected into one long cable or one long mat, because that's not how it's just designed to work. It's just not going to work that way. And at the end of the day, dedicated circuit must be provided for each heating element, just like we indicated on the on all of the installation plans and electrical plans. And when we come down to maintenance, 1 year, 2 year down the road, there's really no maintenance required for the system except wiping off that sensor, making sure it's nice and clean before the start of the season. Just don't want to have any debris kind of interfering with that water or snow that's going to be melting. So just ensure that sensor is clean, takes less than a minute, and your system is maintained.
One thing to remember is, you can't remember it until we tell you. So one thing to remember after we tell you is that make sure that the sensor wire is never in the same conduit as the non-heating leads. That will, as soon as power goes to those leads, you'll lose the signal from your sensor because it just doesn't, it's a low voltage signal with a high voltage signal. And most codes, local codes, do not allow low voltage wires in the same conduit as high voltage wires. And also, it will obliterate the signal from the sensor. So never ever put the sensor wire in the same even though you want to be tempted to do it, never put it in the same conduit as your non-heating leads. So what happens, I can tell you what happened here. I mean, somebody decided they're going to put a handrail in. So someone didn't watch this webinar and they didn't learn to space the cable away from where the handrails were going to go in, and they drilled through the wire. What goes on? How can we take care of that?
So one part that we probably didn't cover today, but that's pretty simple and straightforward. Your green heating cable simply has two conductors inside. That's why we call it a twin conductor system. And it has a ground wire that eventually surrounds those two conductors. If there is just clean big cut or drilling done through that area, all you really need to do at the end of the day to still recondition, can I use the word recondition, reconnect this area is you need to reconnect your two conductors individually and ensuring that they are all insulated. As you can probably see on those pictures, those two tiny heat shrinks are installed on each of the conductors. So eventually you reconnecting each of those and you're reconnecting the ground, making sure that it's, again, back all intact. And you're putting that final bigger heat shrink, the pink color heat shrink, over the whole repair. So of course, you want to ensure everything is nicely isolated from those elements. No water, moisture going to get into it. Everything is nice and waterproof. And that's pretty much, a repair that you need to do to get this fixed.
Yeah, unfortunately, you don't have a magic wand. Can people say, well, what do I do to fix this? Well, I wish I could say, here, we'll send you a magic wand and you can just wave it over there. It'll make everything okay. It's not that simple. But what we do is we do have tools that can find where the bad spot is. We can see it with a thermal camera, and then we know exactly where we need to break up that concrete. The secret is to do it correctly at the beginning, because even if we do get this repair done, you're going to have concrete from two different batches made probably in two different places at two different times of the year. So you're going to probably end up, unless you paint over the top, you're probably going to see where the repair was done. There's no way around that. So the idea there is to just eliminate the repair, and that is to do it correctly, to take those cautions to make sure that nothing happens. But if it does, hey, then you can find out where that spot is and you can fix it and repair it and get it working back again. So we've done this a lot in stairways. We've done it in ramps. We've done it in sidewalks. It does happen, and the repairs can be done. So at this point, we're going to give you some time to ask some questions. And while you're thinking of some questions, let's talk about some questions that we've gotten already from our customers. And that is one of the first ones. We got a question from Brad. And Brad asks, how does this system work with concrete pavers?
Yeah, good question, Brett. And concrete pavers, just like I would, at this point, I generalize because any other paver installation would be pretty similar. One important thing that I don't recall, maybe we mentioned, maybe we don't, but that's an important one to repeat. You don't want to have your pavers, your bricks, your stones to be any thicker than 2.5 inches. That's an important critical thing, because think about 2.5 inches is the limit, but you also have this bed below that paver or brick that's going to be, let's say, another inch or so. So now you're suddenly getting to a distance of 3.5 or more inches from the cable. That just becomes kind of way too much for the heating cable to generate and push that heat out. So first of all, and make sure it's less than 2.5 inches. And generally, you want to have 1 to 1.5 inches of that mortar bed or sand or stone dust below it. That's eventually what you're going to be using to cover that heating element. And yeah, that's going to be pretty much your typical cross section, unless I've got something.
Well, we have an installation cross-section of this in the installation manual of the Snowmelt installation manual. If you're interested in that, we can send you that cross-section. We have cross-sections for all these applications. So feel free to contact us with that, and we will send you your cross-section that you're looking for. The thing is, when it comes to pavers, is you want to make sure that the bed that you're setting the cable in is thick enough. The pavers or the bricks or whatever should never rest directly on the heating cable. They should be resting on the sand that the cable's buried in, because you don't want that cable to eventually wear through the surface of the cable. And to do that, you need to make sure that it rests on sand, not actually on the cable itself. So great question from Brad. The next question is from Rajesh, and their question is melting duration time after the system has been turned on.
Yeah, another great question.
How long is it going to take to start melting?
Yeah. So simply, I'd like to describe it this way. If your sensor is in the right spot and it's getting that, those first snowflakes when the snow storm or just snow event is starting, that means as soon as the snowflakes lands on the sensor and it lands on your driveway, your system going to be already kicked on. And by the time you're going to start developing some potential accumulation, by that time or even before that time, your system already typically will be at that temperature where it will start or be ready to melt. So generally, in those 15, 20 minutes, roughly, maybe more, maybe less, depending on the snow event and lots of other factors, that system will be already at the temperature to start melting the snow. Generally speaking, another, I think, way to say it or approach it, which I feel like I'm using a lot, I say that the system is really designed to never get accumulation on it, no snow accumulation if it's running and set up correctly. So, if it just started to snow, it will warm up, stay snow-free, and the after run time, it would typically even dry out. And of course, we're talking about normal snow events. Anytime it's a blizzard and it's -20 outside, that's not your normal snow event.
Right, a normal snow event depends on where you are in the country, but usually 2 to 3 feet is not a normal snow event, so it will take longer to melt that amount of snow. We had a couple of times last winter where the eastern seaboard got hit by 2 to 3 feet of snow, and people were going, well, how long is it going to take me to melt this snow? It's going to take a while, because that's not a normal snowfall. Normal snowfall, it could take you a half an hour, but for that, it could take you a day and a half. It just depends what a normal snow event is in your area. So it doesn't look like we have any questions here, so let's just continue on and talk about our next webinar, which is going to be everything you need to know about heating concrete floors. It's kind of the same thing as we're talking about here when we talked about concrete. Yeah. That's Thursday, 1 p.m. Central, September 9th of this year. We also have daily trainings that go on here every Monday at 4, Wednesdays at 4, Thursdays at 11 and 4, and Fridays at 11. So you can check us out. If you have a question, you can just drop in on one of our daily trainings, and that's available from our website. You can get right in there. We're having a monthly promotion this month. It's August of this month, 20% off our Environ Easy Mats, which are great for heating carpeting in the U.S., heating laminate in the U.S. and Canada, and floating wood in the U.S. and Canada. Visit WarmlyYours.com for more information about that sale and see if our sizes fit your particular job. You're going to be receiving an email shortly asking about your experience during this webinar, and we appreciate your comments and suggestions. We love to hear what you would like to learn about instead of us just picking some topic out of the air going, no, maybe they'll like this. If there's something to say, hey, you know, I've been dying to know, how does this work? Or why do you do this? Or why is this product used for that? Or how do I heat this particular product? Let us know what that is, and we will be glad to talk about it in one of our upcoming webinars. So if you want to contact us, you can always get a hold of us at 800-875-5285. You can get a hold of us at our email and also on our website, which is WarmlyYours.com. And we're all over social media. Just look for Warmly Yours in your social media platform of your choice. So thank you so much for joining us today. We hope to see you next time. We hope to see you every day of the week during our training seminars. But if you can't join us until next month, we want you to stay warm.
Be radiant.
All right, folks, thanks so much for watching. We'll see you all next time. Have a great day.
Goodbye.